Hi and welcome to another adventure with Mr. Lamb. Today we'll be discussing matrices. So the course outline is what is a matrix, using matrices to represent information, and matrix arithmetic, so addition, subtraction, scalar multiplication, as well as matrix multiplication. So the first skill I guess we're looking at is what is a matrix? So a matrix is information enclosed in square brackets. So the letter D here represents the matrix D, and the matrix D has 4 pieces of information. Now the order of a matrix is represented by the number of rows by the number of columns. So in example matrix D is a 2 by 2 matrix because it has 2 rows and 2 columns. Just a reminder, the rows are the purple lines and the columns are the vertical lines. So we've got a row matrix. A row matrix is just one row. So the order of a row matrix is a 1 by 3. We've got a column matrix. So a column matrix is a matrix that has 1 column, and the order of that is a 3 by 1. The elements of a matrix are the numbers inside that matrix, and they can be represented by the letter A, I, J. Now the letter I represents the row number and the J represents the column number. So in the matrix below, A11 represents the number in row 1, column 1, and A12 represents the number in row 1, column 2. So in this one here, A22 is just the number in row 2, column 2. Creating a matrix from an equation. So let's say that you have to work out the numbers in matrix B. And matrix B is a 3 by 2 matrix. Since it is a 3 by 2 matrix, it will have 6 empty slots or spots. As you can see, 1, 2, 3, 4, 5, 6. Now the element in row I and column J, so the actual number in that matrix, is given by a rule. And that rule is 2I plus J. Now the number in row 1, column 1 would be 3 because row 1 means I is 1, column 1 means J is 1. So we replace the I and the J in the rule with 1 for I and 1 for J, and we work it out, and that gives you 3. And then we just repeat this for every single other element. So for example, row 2, column 1, I is 2, J is 1, substitute it into the formula or the rule, which is here, and you get 5. Do it for row 2, column 2. Which is 6, and then you just repeat it for every other element, and you end up with this answer here, and this is the expanded form of the rule with the correct IJs in there. Example 1, A is a 3 by 3 matrix. The elements in row I and J is given by the rule Aij equals to 2I plus J. The number in row 1, column 1 is 3 because A11 equals 2 times 1 plus 1, which equals to 3. Remembering that row 1, column 1 means I equals to 1, J equals to 1. So if we sub it into there, we get the answer of 3. Row 2, column 2 means I equals to 2, J equals to 2. We sub those into the formula or the rule, and you end up with 6. And you just repeat for every single other one. And you end up with matrix A, which is 3, 4, 5, 5, 6, 7, 7, 8, 9. Just keep in mind the rule generally uses a little lowercase letter, and the actual matrix is reserved for capital letters. Switching rows and columns. If you ever need to switch the row or column and columns of a matrix, we call that the transpose of a matrix. So the transpose button can be found in the book. As you can see here, we have a 2 by 4, and when we transpose it, we end up with a 4 by 2. So the rows and the columns will switch over. The book is in the button next to the button next to 9, and the T is what you're looking for, the little T for transpose. We've got square matrices, so matrices with the same number of rows and columns. Only these matrices have inverses, which will be important for further on. Square matrix example will be a 2 by 2 or a 3 by 3. Then we've got diagonal matrices. In these matrices, the leading diagonal, which is the diagonal from the top left to the bottom right, have numbers, but the rest are zeros, as you can see here. The identity matrix is the same as the diagonal matrix, except that the leading diagonal are a set of 1s and the rest are zeros. It's important to note that anything multiplied by an identity matrix is the same matrix. Identity matrix is like a 1. So 3 times 1 equals 1. 4 times 1 is still 4. 10 times 1 is still 10. So anything multiplied by the identity matrix is still the same. We've got symmetric matrices. So in these matrices, the numbers are mirror images of each other along the leading diagonal. The numbers in the top half are the same as the bottom half, as you can see there. We've got triangular matrices. Now, an upper triangular matrix is a square matrix where all the numbers below the diagonal are zeros, as you see in the example. In terms of a lower triangular matrix, it's also a square matrix, but where all the numbers above the leading diagonal are all zeros. (2016) Federal Maths Exam 1, question 1 was find the transpose of that, which isn't too hard. Grab your CAS calculator, make sure you go to calculator, go to creating a matrix. It was a 2 by 3, so 2 rows, 3 matrices, and then put them in. I used the tab button to go between each of the elements, it's easier. The transpose button is in the book. Now mine's at T. If yours is not at T, just push the letter T on your CAS, it'll jump straight there. Hit enter again, and there's your answer. So the answer to this question was C. Hello, so this question 5 was a question from the 2016 Federal Maths Exam 1. We've got a matrix here which has an order of 2 by 4. The elements in row I and column J of M is Mij. The elements of M are determined by the rule. So unfortunately for this one, you're going to have to check off each one at a time. I recommend maybe checking some extreme numbers. Let's check the first one and the last one. So the first one is in row 1, column 1. Which means I equals to 1, J equals to 1. So if I use this first one, if I equals to 1 as 1 plus 1 minus 1, which equals to 2 minus 1, which equals to 1, that checks off. Check the second one, that's 2 by 1 minus 1 plus 1, which equals to 2, and that doesn't check off. The next one, we've got 2 by 1 again, plus 1 minus 2. This time is 2 plus 1 minus 2, which equals to 1. That checks off. This one here is 1 plus 2 minus 2, which equals to 1. That checks off. And then E, we've got 1 plus 1 plus 1, which equals to 3. That doesn't check off. So we eliminate B and E straight away. Now I'm going to check the extreme, which is 6, which is row 2, column 4. So that means I equals to 2, J equals to 4. So in the first one, I equals to 2, so that's 2 plus J, which is 4 minus 1, which equals to 5. Now that number there is a 6. This number we got is a 5, so that doesn't work out. Let's check C. For C, we've got 2 times I, which is 2, plus J, which is 4, minus 2, which equals to 8 minus 2, 6. This one checks off. And the last one that we need to check off is this one, where I is 2, J is 4, so that's 2 times 4 minus 2, which ends up being 8, so that does not work either. So the answer to this one must be C, because we checked 2 numbers and they both produce the correct number there, which is a 6. Thank you. Alright, we'll move on from there. So 2016 Federal Maths Exam 2, a travel company arranges flights, hotels, performances, and tours. Matrix C contains the number of each type of booking for a month. Write down the number of the matrix C. So the order just means how many rows, how many columns. This one has 4 rows, 1 column. So the answer is a 4 by 1 matrix. 2017 Federal Maths Exam 1. Kai has a part-time job. Each week he earns money and saves some of his money. The matrix shows the amount earned and saved in dollars in each of the 3 weeks. How much did Kai save in week 2? So make sure you read the question carefully, save, and read what the letter represents for save, which is S. So we're looking at this column here, and we're looking for week 2, so this column and this row, and that means the answer is B, $90. 2017 Further Maths Exam 1. Now this one was a bit annoying. This was the second year this type of question had come out from memory. Table shows information about two matrices, A and B, and your job is to find the sum of A and B. So, alright, this is 2017 Further Maths Exam 1, question 6. The table below shows information about two matrices. So matrix A is a 3 by 3, matrix B is a 3 by 3. There's a rule for matrix A, which is 2i plus j, and for matrix B, the formula is I take away j. Now the question is asking for the sum of matrix A and B. So it's kind of a two-step process. You need to work out the matrix of A and then the matrix of B, and then sum them together. Now let's just go. Now it's good to have a look at different numbers on the answers. Multiple choice question, always look for things to your advantage. So what I see is this number is generally different for everyone. So let's circle that, except for these two, which is fine, not too bad. Now I'm going to focus on that number because I don't really want to work out the entire matrix. I just want to work, that takes way too much time. So what I'm going to do is just work out this number, and hopefully it eliminates some of them. So that number there is in row 2, column 3. So the matrix A, the formula is 2, so that means I equals to 2, J equals to 3. So I'm going to use 2 times 2 plus 3, which is 4, plus 3, which is 7. So that's for matrix A. For matrix B, it's I take away J, so I is 2 take away J, which is 3, which is negative 1. Then we need to add them together, so 7 minus 1 equals to 6, which means our answer is most likely D. Now it's good to check another number just in case. I know that most of the time we'll get it right the first time, hopefully. We can check the first number. So the first number is in row 1, column 1. Okay, quite easy. That means I equals to 1, J equals to 1. So matrix A, it's 2 times 1 plus 1, which is 3. Matrix B, which is I minus J, so it'll be I, which is 1, take away 1, which equals to 0. 3 plus 0 equals to 3. Yes, most likely that answer there. And that's how we do those. So I would recommend you don't have to work out the entire matrix. Pick a number that is slightly different for each set and go from there. If we want, I'll work out one more just in case. Picking something that's slightly different for all of them would be that one there. So that one there is in row 3, column 2. That means I equals to 3, J equals to 2. So in matrix A, we're looking at 2 times 3 plus 2, 6, which is 7, 8. In B, we're looking at I minus J, which is I minus J, which is 3 take away 1, which is 2, and A plus 1 equals to 9. So that kind of eliminates those ones there, and you're left with these two. We'll check them off. There's 2 numbers there. So most likely the answer is D for question 6. Thank you. Okay, we'll move on. So 2017 Further Maths Exam 2 again. Question 1. School canteen sells pies, rolls, and sandwiches. The number of each item sold over 3 weeks is shown in matrix M. In total, how many sandwiches were sold in these 3 weeks? So the question is sandwiches in total. So sandwiches was this column. So in total, you just need to add them together, and you end up with 159. Now the next question is, what does the element M12 mean? So 1, 2 means row 1, column 2. So row 1, column 2, we're looking at the 24 there. The 24 is the number of rolls sold in week 1. So I've written the response, the number of rolls sold in week 1. I should add the number of rolls sold in week 1 is 24. Okay, so just make sure you quote the value 24 as well. Very important. Alright, our second skill is using a matrix to represent information. So there's using matrices to represent tables. So we've got a table here, and it's pretty much a direct transformation into a matrix. So as you can see, we're looking at males, we're looking at females, and we're looking at automatic cars and sports cars. So you can already kind of see that it's going to be most likely a 2 by 2 matrix. So that's what we'll do. We'll put males, and then we'll put automatic and sports cars. Another way we use matrices is to represent network diagrams. So as you can see here, it's good to drop a blank matrix once you've started counting how many vertices there are. So this one's got 1, 2, 3, 4. So I'll go 1, 2, 3, 4, 1, 2, 3, 4. Just keep in mind, if I go 1, 2, 3, 4, this one must go 1, 2, 3, 4. I can't go 1, 2, 3, 4 and then 4, 3, 2, 1. Just make sure the order is the same. So in terms of using matrices to represent network diagram, if there's a connection between a direct connection between 2 points, we put a 1. If there isn't a direct connection between 2 points, we place a 0. If there are more than one connection, we put the number of connections required. A loop counts as 2, so keep that in mind. And as you can see, 1 cannot go to 1 by itself. 1 can go to 2. 1 can go to 3. 1 can go to 4, etc. Rule for the sum of the rows. So for example, row 2 has a sum of 3, which means that there are 3 connections to point 2. The first skill is matrix arithmetic, addition, subtraction, scalar multiplication, and matrix multiplication. So only matrices of the same order can be added or subtracted from each other. Please make that very clear. It will save you a lot of trouble. So for example, this is a 2 by 2 matrix plus another 2 by 2 matrix, which means you're going to end up with a 2 by 2 matrix. Same with subtraction. So if I use this one as an example, this one is a 3 by 2 matrix plus a 2 by 2 matrix. They're not the same order, therefore you cannot add them together. Equivalent matrices. Equal matrices can be solved by making the corresponding elements equal and then using the solve function on your CAS. So for example, we need to solve for A in the matrix below. So that means this element is the same as this element. That means A plus 2 is the same as 6. So since the two matrices are equal, then we can say that A plus 2 equals to 6 since they belong to the same element. If your algebra is not too great, you can use the solve function on your CAS. Solve function is menu 3.1. So you just need to type solve A plus 2 equals to 6, comma A. No need for the comma at the end of it. And the answer is A equals to 4. Scalar multiplication is just multiplying a matrix by a certain number. So for example, if I need to multiply this matrix by 3, there's a 3 at the front. You just need to multiply every single number inside that matrix by that number. Although I haven't seemed to find a trick on how to factorize matrices, there is a small trick around it, I guess. Let's say we've got this matrix here, and we need to take out the highest common factor. To extract the highest common factor, you need to use a function on the CAS called GCD. Once you use that function and do it similar to this, you'll get the answer of 4. Once you got the 4, you just need to remember to divide everything inside that matrix by 4 to give you the correct answer. The GCD function is in menu 2.5, so menu number greatest common divisor. And as you can see here, you need to do GCD, which comes up once you type greatest common divisor. Put the first number in, which is 12. Bring up GCD again, bring up the second number, 36. Bring up GCD again, and put the last two numbers. So GCD only seems to work between two numbers, and that's why we need to put so many GCDs in there. Just a refresher on percentage decrease and increase. A 10% increase will become 1.1. A 25% increase becomes 1.2. To get the 1.1, we do 1 plus 10 on 100. And to get the 1.25, we do 1 plus 25 on 100. Similar to decrease, a 10% decrease means we're multiplying by 0.9. To get the 0.9, we go 1 minus 10 over 100 instead of 1 plus. The 25% decrease is 0.75 because 1 minus 25 over 100. Matrix multiplication. The order of matrix multiplication is extremely important. For a matrix multiplication to happen, the multiplication must first be defined. For a matrix multiplication to be defined, the number of columns in the first matrix must be the same as the number of rows in the second matrix. Now that sentence is a handful, so it's better and easier to show you. If you've got two matrices and they're multiplying each other, just make sure that the two numbers in between are exactly the same. If they're different, then it won't work. So since the two numbers are the same, then the matrix multiplication is defined. In this example, since the two numbers are different, then the matrix multiplication is not defined and will not multiply out. The order of the resultant or product matrix is the number of rows in the first matrix and the number of columns in the second matrix. Once again, quite a lot to take in, easier to show you. When I take these two matrices and I multiply them, the result matrix or the answer matrix will be of order 3 by 4. So it will take the first number and then the last number there. So since the two numbers are the same, the matrix multiplication is defined, so we can go and multiply this out. So we can check off that 3 by 2 multiplied by 2 by 4 will become a 3 by 4. And here's just me doing it on the CAS just to prove to you is right. So that's a 3 by 2 multiplied by 2 by 4, and that gives an answer of a 3 by 4 matrix. Matrix multiplication by hand, you do need to know how to do this. So matrix multiplication is just a combination of multiplying and adding. Let's take this 2 by 2 matrix as an example. Step 1, work out the order of the resultant matrix. That generally helps. So there's a 2 by 2. Now, the first number in row 1, column 1, is this one here. Row 1, column 1. To get that answer, you need to multiply the first number in row 1. So this is row 1 of the first matrix. So row 1 of the first matrix by the first number in the column 1 of the second matrix. And then add this to the second number in the first matrix in row 1 multiplied by this by the second number in column 1 of the second matrix. So essentially it's going to be 2 times 4 plus 8 by 8 to get this first number. The next one, which is this box here, will be 2 by 6 plus 8 by 10 to get this top one. When you finish the top row, you go to the bottom row. So instead of using that top row, we're going to repeat what we did with the bottom row. So to get row 2, column 1, it will be 4 by 4 plus 6 by 8. And to get row 2, column 2, 4 by 6, 6 by 10. Another example is this one here. So as you can see, we've got blue lines and orange lines to get the green circle. First number in first row by first number in first column plus second number in first row by second number in first column. So as you can see, this is the calculations for row 1, column 1. And these are the calculations for row 2, column 1. So yellow line and orange line to get the yellow circle. First number in second row by first number in first column plus second number in second row by second number in first column. And then you repeat for the second column. Summing matrices together. In order for you to sum the row of a matrix, you just need to post multiply the matrix by a column matrix with all ones. So post multiply meaning I put the matrix the column matrix of ones afterwards. To sum the columns of a matrix, pre-multiply the matrix by a row matrix with all ones. So pre-multiply meaning I put the row matrix of ones before the actual matrix, and it will add it all up for you. Writing simultaneous equations. So in this one, you need to convert a set of simultaneous equations into matrix form, following the bottom example. The numbers in the front of the variables goes into one matrix, and the variables go into another matrix, and the solutions will go into another matrix after the equal sign. So for example, 2x plus 3y equals to 4, and 3x plus 2y equals to 4. First of all, make sure it's lined up, the x's and then the y's underneath each other. So when that's done, all you have to do is transfer the numbers. So the 2x, the 2 goes here. The 3y, the 3 goes here. The 3x, the 3 goes here. The 2y, the 2 goes here. And then the 2 4's go at the end. And the two variables are x and y, so they go here. Any missing variables must have a 0 in their spot when converting into a matrix, and remember those negative values. So second example, we've got 2x plus 3z equals to 1, 2x minus 1y minus 2z equals to 4, 2y plus 3z equals to negative 1. As you can see, there's 3 variables here, so there should be x, y, z. And this one will have a 0 where the y is, and this one will have a 0 where the x is. Application of matrices. So these are always a bit annoying, but for me, when I do it, you need to make sure you pick a matrix multiplication that will be defined. Find out what the question wants. Is it the total energy or the total number of students per house color? Make sure that the column of the first matrix matches the rows of the second matrix. Check if the resultant matrix order is what is required. If it's the total energy, then it should be a 1 by 1 matrix. If it isn't, repeat the above steps. So example 1, a game of football between cats and dogs. Cats score 15 goals, 4 behinds. Dogs score 9 goals, 11 behinds. A goal is worth 4 points and a behind is worth 1 point. How many points do the cats and dogs score? So there's the information put in the matrix. So we've got cats and dogs, goals and behinds, and a goal is worth 4 points and behind is worth 1 point. So the resultant matrix requires 2 answers, a value for cats and a value for dogs. So we're looking for a 2 by 2 matrix. Now we know that this is a 2 by 2 matrix and this is a 2 by 1 matrix. Now if we switch the two matrices, it's not going to work. So if I multiply this out, we get a 2 by 2 matrix multiplied by a 2 by 1 matrix. Our resultant will be a 2 by 1 matrix, which gives us the correct answer. However, if I switch them around, I'm going to get a 2 by 1 matrix multiplied by a 2 by 2 matrix. That's not going to be defined. So you can use that to check a bit of common sense as well. So if I just do this multiplication, a 2 by 2 multiplied by a 2 by 1, I'm going to get this answer, which gives you 2 values instead of a 1 or none. Example 2, let's say we've got matrix E. It represents the energy in kilojoules per minute for walking and running. We've got matrix T, which is the time a person spends walking and running. Now I use a matrix multiplication to calculate the total energy from walking and running. So I want the total energy from walking and running, which means it's going to be a 1 by 1 matrix. So if I've got E, which is a 2 by 1 matrix, and T, which is a 1 by 2 matrix, and if I try ET, I'm going to end up with a 2 by 2 matrix, which is too much information. If I try TE, we're going to get a 1 by 1 matrix, which is exactly what we want. So that's what we can do by using common sense. Matrix powers. A matrix can be raised to a power if it is a square matrix. So for example, this can be defined and be calculated. This is not defined and it cannot be calculated. 2016, Further Maths Exam 1. Matrix product that multiplied by leaps is equal to what? So as you can see, all you have to do is enter all of that into a CAS calculator and it'll spit out an answer. The answer is pails. So the answer was D, pails. 2016 Further Maths Exam 1. The table shows the number of each type of coin saved in the money box. Alright, we're looking at 2016 Further Maths Exam 1, question 4. The table below shows the number of each type of coin saved in the money box.
So you got 5 cents, 10 cents, 20 cents, 50 cents. You got the number 15, 32, 48, and 24. Now the matrix product that displays the total number of coins, so we got one information, and the total value of these coins. So we're looking for two pieces of information. So either it's a 1 by 2 or a 2 by 1. So that's what I'm going for first. So this one here is a 1 by 4 and multiplied by 4 by 1, which ends up being a 1 by 1. So this can't be the right answer because we're looking for two pieces of information. That means it can't be this one here. This is also a 1 by 1. Now here we've got a, what's this one? 1, 2, 3, 4. There's a 1 by 4 versus a 4 by 2. So this, you'll end up with a 1 by 2. So that's a possibility. Here we've got a 2 by 4 and a 4 by 1. So here we'll end up with a 2 by 1, which is another possibility. And here we've got a 1 by 4 as well as a 4 by 2. So this ends up by 1 by 2. So you got these two possibilities here. I guess the next thing you'll be looking for is when you actually multiply these out, what would you end up with? So the question is the total number of coins. We can kind of figure this out. The total number of coins is going to be, add all these up. So that's 15 plus 32 plus 48 plus 24. That means there's 119 coins, and then the worth of it will be that times that, and then add it all together. Obviously we can't do it like that because we're looking for the matrix. Now, so that means we've got three choices. I guess the easiest way would be to multiply them out. So keeping in mind, we need to have the total number of coins, and to get the total number of coins we need to add up 15, 32, 48 and 24. So we need to add these up. So I don't believe it's going to be this one, because this is the coins 5, 10, 20, 50, and multiply it by a column means you're going to add those numbers up, and I don't need to add up 5, 10, 20 and 50. I need to add up this row. I need to add up the 15, 32, 48 and 28, which most likely means that I'm going to need this one here, because the column of ones means that I'm going to add all these numbers up. This is the number of coins, and then the numbers down here are the worth. So there's 15 5-cent coins, 32 10-cent coins, 48 20-cent coins, 28 4 50-cent coins. And when you do matrix multiplication, is a series of multiplying as well as adding. So it's going to be 15 by 5, which is 75, plus 32 by 10, plus 48 by 20, plus 24 by 50. So I guess you kind of need a good understanding of matrix multiplication. So this one here will be the right answer. In this one, we're adding, the multiplying by columns of ones means we're adding the numbers together. So 5 by 1, 10 by 1, 20 by 1, 50 by 1. If I do that, that will add up the coin. Doesn't make sense. I'm adding a 5 cent plus 10 cent plus 20 cent plus 50 cent. So that doesn't make sense because I want the total number of coins as well as the total value of coins. So that one is not the correct answer as well. So the answer is B for that one there.
Okay, moving on. So this time, 2016 Further Maths Exam 2, a travel company arranges flights, hotels, performances, tours. Matrix C contains the number of each type of booking. A booking fee per person is collected by the travel company for each type of booking. Matrix G contains the booking following. Calculate the matrix J plus GC, and then what does J represent?
Okay, this is 2016 Further Maths Exam 2. Travel company arranges flights F, hotel H, performance P, and tour T bookings. Matrix C contains the number of each type of booking for a month. A booking fee per person is collected by the travel company for each type of booking. Matrix G contains the booking fees in dollars per booking. So first part, calculate the matrix J, which is G by C. So G by C is simply that times that. So on your CAS, put our matrix button there. I need a custom one because I need to do G by C. G is a row 1 by 4. It's 40, 25, 15, 30, multiplied by C, which is a 4 rows, 1 column. So that's 85, 38, 24, and 43. And that gives you a total of 6,000. So to calculate the matrix product J, that's 6,000. So the matrix product goes in a set of brackets, so please make sure that's there. You cannot just write 6,000. And what does J represent? So this is the booking fee, and this is the number of bookings. So this would be the total amount received by the company as booking fees, I would say. Booking fees. Because these are the booking fees for a flight. There was 85 flights, so 40 by 85 will give you the amount that's received by the company for fees for flights, and then for hotels, for performance, and then for tours. So the total amount of $6,000 received by the company as booking fees. And that's that. Thank you.
Okay, moving on. Which is the first lesson summary. So here's what we learned today. First skill, what is a matrix? Second skill, how to use matrices to represent information. And third one is matrix arithmetic, just adding matrices, subtracting matrices, scalar multiplications, as well as matrix multiplications and their applications. And that's it. Thank you very much.